Welcome back, everybody. Now we continue with the partial fractions. So we're learning another type, the technique for resolving another type of fraction into partial fractions. Let's take it. Resolve 2x squared plus 3x plus 3 all over x plus 1 times x plus 2 into partial fractions. First of all, if we expand this denominator, we're going to get x squared plus 3x plus 2. And we'll see that the degree of this denominator is 2, and that of the numerator is also 2. Yeah, that of the numerator is also 2. By the way, the degree of a polynomial is simply the highest power in that polynomial. So the highest power in this polynomial is 2. That means this polynomial is a degree of degree 2. And the highest power in this polynomial is also 2. That means this polynomial is also a polynomial of degree 2. Now, if the degree of the numerator of a fraction is greater or equal to that of the denominator, then that fraction is an improper fraction. I say that again. If the degree of the numerator is greater than that of the denominator, or it is equal to the degree of the denominator, you say that that fraction is an improper fraction. So the two conditions are, it's either the degree of the numerator is greater than that of the denominator, or it is equal to that of the denominator. If that happens, you say that the fraction is an improper fraction. And how do you resolve an improper fraction into partial fractions? What you do first of all is to reduce that improper fraction to a proper fraction. Let's see how that is done. So that's what we're going to do here. We already know that this fraction is an improper fraction. So we have to divide the numerator by the denominator to reduce it to a proper fraction. So that means, let me write it this way. I want to write the expansion of the denominator. 2x squared plus 3x plus 3 over x squared plus 3x plus 2. That's the denominator. X squared plus 3x plus 2. Now, I want to divide the numerator by the denominator. I'm using the method for dividing polynomials. So 2x squared plus 3x plus 3 is the dividend. That's the numerator, or dividend simply, while the divisor is x squared plus 3x, or simply the denominator, plus 2. Now let's go. To divide a polynomial, this is how you go. You divide the first term of the dividend by the first term of the divisor. And that means 2x squared divided by x squared. That's going to be 2. And every time you divide that way, you multiply the whole of this by that answer. So now I'm going to multiply x squared plus 3x plus 2 by the 2 on top. So that means 2x squared. I'm multiplying the whole of this by 2. So that means 2x squared plus 6x plus 4. Now I'm going to subtract. And what do I get when I do that? Let's see. 2x squared minus 2x squared is 0. 3x minus 6x is minus 3x. And now 3 minus 4 is minus 1. So there you go again. I'm supposed to divide this by this, but 3 minus 3x, the degree of minus 3x is less than that of x squared. So I'll just stop there. When you see that, you stop. But if I get a degree that is the same or greater, I'll divide. So that means the answer is, that simply means 2x squared plus 3x plus 3 divided by x squared divided by x squared plus 3x plus 2 is the same as, what you do here is excuse me, write the quotient, that's 2 plus, then you write another fraction, that is this remainder all over the divisor. So that means plus minus, let me put it in brackets, 3x minus 1 all over I want a straight line, x squared plus 3x plus 2. Yeah, so here I can write that as 2. Okay, I think I can even just leave it that way. Okay, or maybe let me write it this way, 2 minus, let me show this, I want it to be very clear, that's 2 minus into brackets 3x plus 1. I'm factoring minus 1 out of the numerator of the fraction, plus x over x squared plus 3x plus 2. I hope that's clear. Yeah. So now, if I open the brackets, it's going to become 2 minus, plus times minus is minus. So that's 2 minus 3x plus 1 over x squared plus 3x plus 2. That's it. Now I've reduced this improper fraction, the compound fraction, which is an improper fraction, into a proper fraction. So what I will just do now is resolve this into partial fractions, and that's all. So let's see. So let me do that very quickly. I'm resolving 3x plus 1 over x squared plus 3x plus 2 into partial fractions. But I know that x squared plus 3x plus 2 is the same as x plus 1 times x plus 2. So let me write that 3x plus 1 over x plus 1 x plus 2, and that's equal to a over x plus 1. So that simply means I'm doing 3x plus 1 over, I'm resolving 3x plus 1 over x plus 1 times x plus 2 into partial fractions. That's a over x plus 1 plus b over x plus 2. The LCM is the product x plus 1 times x plus 2, and that's a into brackets x plus 2 plus b into brackets x plus 1. So that means 3x plus 1 is equal to a into bracket x plus 2 plus b into bracket x plus 1. Now if I put x equals minus 1 in this equation, I'm going to get, on the left hand side, I will have 3 times minus 1 plus 1 equals, if I put x equals minus 1, this will become 0, because minus 1 plus 1 is 0. So if I multiply that by b, that will be 0. And I'll be left with a into bracket minus 1 plus 2, which simply means minus 3 plus 1, that's minus 2. 3 times minus 1 is minus 3 plus 1 minus 2 equals minus 1 plus 2 is 1 times a. So a equals minus 2. Now if I put x equals minus 2 in the identity, that means 3 times minus 2 plus 1 equals minus 2 plus 2 is 0, so a will be gone, and I'll be left with b times minus 2 plus 1. So that means this is minus 6 plus 1, which is minus 5, equals minus 2 plus 1 is minus 1 times b, that's minus b. So that means b is equal to 5. Now we've got the constant a and b. That simply means 3x plus 1. Let me even copy that. That simply means this fraction, that means 3x plus 1 over x plus 1 times x plus 2 is equal to a, which is minus 2 over x plus 1 plus 5 over x plus 2. Now, the original equation, we can now say the original equation, which is an improper fraction, and that's this. That's this. That's this is equal to, yeah, let's paste that, is equal to, because I remember that when I reduced it to a proper fraction, I got this. So this is what I'm going to do. It's going to be equal to 2 minus, and now I know that this one is the same as, okay, let me write it this way first of all. That original equation is this. I split it into this, so let me write that. The original equation is the same as this. Is equal to this. And of course that's the same as this, and I know that this one is this. So that means 2 is the same as 2 minus, I want to put that in bracket, minus 2 over x plus 1 plus 5 over x plus 2. The idea is that you reduce the improper fraction to a proper fraction, and then you resolve the proper fraction into partial fractions. When you reduce the improper fraction to a proper fraction, you are going to get a part that is maybe just a constant and another part that is a proper fraction. So you resolve that proper fraction into partial fractions, and then you put them together in the end, at the end. So that's what I've done here. X squared plus 3x plus 2 is x plus 1 times x plus 2. So now I can open the bracket. That's 2 plus, if I open the bracket here, minus 1 times this is going to be plus 2 over x plus 1 minus 1 times plus 5 over x plus 2 will be minus 5 over x plus 2. So that simply means therefore that 2x squared plus 3x plus 3 over x plus 1 times x plus 2 equals 2 plus 2 over x plus 1 minus 5 over x plus 2. And that's it, very, very simply. You only have to remember the method for dividing polynomials so that you can reduce the improper fraction to a proper fraction and then resolve the proper fraction part of the new fraction, of that result into partial fractions, as we have done. And that's it, very, very simply. I think I want to stop here and take another example on these in the next. So I'll catch you in the next. Bye bye.